As I was rewatching The Adventures of Bart and Sparky, it dawned on me that this class has not seen explicitly that matrix with sines and cosines of thetas and all that. So I'm going to give you a quick rundown on that. Suppose we are in just the normal XY plane. And you know that one of the ways to figure out the matrix for transformation is to figure out where the standard basis go. So let's say we have, here is 1, 0, 0, and here is the other one, 0, 1. Now we have to write this bigger. Suppose we rotate the entire plane, was that counterclockwise, by theta degrees. So where do my vectors end up? Makes more sense. So I rotate this up here. This is my theta. Well, from trigonometry, hopefully you remember that this point is going to be r cosine theta, r sine theta, where r is the length of the vector. But this vector has length 1, so for us, I know t of 1, 0 is going to go to cosine theta, sine theta. Now, what about the other one? So here we go. I'm also going to rotate this by theta. But if I want to figure out what this point is with respect to the x-axis, because that's how you do those points, t of 0, 1 has been mapped to cosine of 90 plus theta, sine of 90 plus theta. Now, when you do some trig simplification, cosine of 90 plus theta is negative sine theta, and sine of 90 plus theta is cosine theta. If you want, I can show you how to solve this. I use the sum and difference formula for cosine and sine, but that's really not the point of this class, so I didn't want to get too hardcore into trig. So if I want to know the matrix for rotating the entire plane by theta going counterclockwise, the matrix will be cosine theta, sine theta, negative sine theta, cosine theta. What's really cool, if you notice, is if you took the determinant of this, you would get cosine squared minus the negative sine squared. So cosine squared plus sine squared, which is 1, which is kind of cool. So you know that it rotates, but nothing changes size. Just like the 3 blue, 1 brown said, that the determinant of the transformation tells you how big a 1 by 1 block would change in volume, or sorry, in this case, area, under a transformation is equal to the determinant. So that is where this matrix came from in the transformation. And that's a good place to stop.